Hello students, I am Dr. Tanmoy Vishwas. I welcome you all in my channel Chemistry, the Mystery of Molecules. I hope you all are fine. So today we are going to discuss a multiple choice question or MCQ about ester. Ester means you can see this diester. Okay, reaction, sequential reaction with reagents are provided, and this is so ultimate product is B. So the question is, what is the correct structure of the B? Okay, so in order to find out the answer, 4 options are provided and one of them is the right answer. So your task is to find out the right answer. So I first request you, please pause the lecture and try by yourself. Don't worry, I shall provide the answer after some time, but in this way you can do one thing, that is self-evaluation, because it is highly desirable to know how much I know, how much I don't know, what is my capability and which I can't do. Based on that, we can make our effort strategy for the future, and I believe this can provide you success. Okay, fine. So I believe you have paused the video and tried by yourself. So let me explain the answer. So as usual, at first we need to know the nature of the reagent. What is the property of the reagent? See, this molecule is actually a diester. Okay, but it is not symmetrical. Why? See, this OMe is para to this one, and we know that phenolic ethers are orthopara oriented. So since we have two ester group, ester number 1 and ester number 2, we can expect the ester number 2 is more electron deficient, because ester number 1 is in direct conjugation, means it will give here, it will give here, this will come. So in this way, the electron deficiency is somewhat reduced for para substituted. So 1 is actually a para substituted isomer. Fine. So this we understood. This is the aromatic ester, diester, and we know that ester can undergo Claisen ester condensation, but condition is it must have alpha hydrogen. Fine. Okay, so let's discuss. By the way, I have already uploaded a dedicated lecture on Claisen ester condensation. Please visit that lecture for better understanding. Fine. So now let's look at the second reagent, that is sodium hydride along with that ethyl acetate. So sodium hydride is actually a base. Just remember that sodium hydride is a good base, whereas sodium borohydride is a good nucleophile. Fine. So if sodium hydride acts as a base, which proton it abstracts? The alpha proton of ester. So you may consider that this is CH2 attached to one hydrogen, and this hydrogen is abstracted by this H minus, because this hydrogen is delta plus, so abstracted. Acid base reaction, and what it produces hydrogen gas, which goes out from the equilibrium. That's why reaction proceeds, and this produces one alpha carbon ion type. Okay, so it's a carbon based nucleophile, and it has a resonance stability. How? This negative charge can come here, it can open, so like enolate, it can stabilize. Okay, so this is the canonical form for the stabilization of the intermediate, this carbon ion, which is acting as a nucleophile. Fine. So nucleophile is generated. So what we can expect? The nucleophile will attack the electrophilic center. And which one is the electrophilic center? Just some time before I told this meta ester is more electrophilic. Fine. We will discuss after some time in details. Fine. Second step, the reagent. This is a diazo or nitrogen transfer reagent. Okay. So this is actually a azide attached to, so you may consider as a tosyl azide, means TSN3. Okay, so this is a diazo or nitrogen transfer reagent in presence of a nucleophile, means nucleophile can attack here. Fine. And the fourth reagent is actually tertiary butyl oxychloride. So we know that oxychloride, oxygen has a -2 oxidation state and chlorine has a +1. Why chlorine is +1 oxidation state? Because the electronegativity of oxygen is higher than chlorine. That's why it is presumed that the electron density is pulled towards the oxygen center. Fine. So chlorine is in plus oxidation state. So you may consider this is actually a oxidant. it will oxidize someone such that this chlorine will come to -1 oxidation state or chlorine minus. So that is the target. That means this reagent is capable of oxidation as well as chlorination, because chlorination means, for example, if you think this CCl, in this case also chlorine has -1 oxidation state, that's why the same thing is achieved. Fine. So now we have understood the nature of the reagent, so let's discuss the reaction. And please remember that this alpha haloester will be converted into the sodium salt of this enolate derivative, means enolate from ester. Okay, fine. Now, so as I told that there will be a reaction that is cross Claisen condensation, but cross Claisen. Okay, let me give you some more details. See, in the reaction medium you have this ester here, means aromatic diester, along with that ethyl acetate, both are ester. So why cross Claisen ester condensation? Okay, why cross Claisen? Answer of the question is, see, these aromatic esters are more electron deficient compared to aliphatic. Why? Because they are attached to an electron, means aromatic ring, and another thing aromatic ring and two ester attached to one molecule. You may say that, sir, there is one OMe. I agree, it is present, but it is not that much high that its electron deficiency will be quenched that much. Fine. And another thing, after delocalization, the oxygen will have a formal positive charge, and you know the oxygen is a highly electronegative atom, so it do not like to have a permanent positive charge on it. Okay. Second thing, if you look at ethyl acetate, means this molecule, let me draw it again. So this is the ester, it is attached to a methyl group which has the plus I effect. So consequently the electron deficiency of this carbonyl group is somehow reduced. Okay, in this case plus I is there, so reduced. And another thing, that Claisen ester condensation is a reversible reaction. Please remember this term, Claisen is a reversible reaction. So logically some molecule may react, means homocoupling, means same Claisen condensation, same molecule like ethyl acetate and ethyl acetate, but ultimately that product will be the major product where the stability is more. Okay, so I have discussed Claisen condensation in details in lectures. I shall provide the link, please visit, you can learn more. Okay, fine. Now let's discuss the mechanism. So after proton abstraction, this carbon ion will act as a nucleophile, means negatively charged, and it will attack this meta position carbonyl. So after opening up, it will leave. And by the way, I request here, please careful where base is consumed, where base is generated. Okay, please be careful, please look at properly. So this, now what happened in this case, look at this, the carbon ion is attached to the carbonyl group and one molecule of base is generated, OMe left. Fine. Now just look at this molecule, this is actually nothing but an active methylene compound and more acidic. What do I mean by the statement active methylene compound? Active methylene compounds are nothing but, you may consider 1,2 dicarbonyl derivatives. Okay, there are many, but this is. So what happens, why they are acidic? Because if I say something acidic, we need to consider the stability of conjugate base, which looks like this, and this conjugate base is doubly stabilized through the conjugation of two carbonyl group, means in this way. So what is the consequence? This. So similar way, another canonical form is possible for the stabilization of the negative charge. So that is the reason why it is stable. Fine. So what we can expect, that under sodium hydride reaction condition, which is basic, this can generate this carbon ion. Will it be able to generate carbon ion from this active methylene compound? Obviously yes, it will do it very easily. So if it do, what it will result, it will consume one proton and generate this proton and generate this carbon ion. Fine. Now this carbon ion is also nucleophilic in nature. Okay. although it is softer, not that much nucleophile like initial one, but it is nucleophilic in nature. So what it can do, it can undergo further reaction. How? See, this can attack here. Now you can consider that, sir, why it will attack? The answer of the question, you have to count how many, it's a ring formation, intramolecular cyclization. So how many number of ring formation possible? 1, 2, 3, 4, 5. And we know that 5-member ring formation is kinetically favored. Okay, and 5-member rings are almost planar in nature. So it will attack, it will open up, it will come back, and ultimately these OMe will leave. So ring closure and parallelly OMe produce. So this is, you can see, look at base generation. Fine. So previously one molecule of base here generated, which consumed the proton from this active methylene compound to produce this carbon, and this carbon again regenerated the base. So please be careful. Now just imagine that there is another proton left, and previously we told that from compared to ethyl acetate, these 1,3 dicarbonyl compounds are more acidic. Okay, actually this is a di of dicarbonyl, means there is one C double bond O, one C double bond O, one ester. So it is true, so much acidic. And for a comparison, I can give you a data. Data means melanonitrile means CH2 CN CN. It has a pK near about 9 or 10. I am not sure exactly. Please check by yourself. Around 9 pK. But whereas if you take its tricyano derivative, means CN 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 CN, and there is one hydrogen, this, its pK is near about -5. I have already uploaded a dedicated lecture on tricyanometane. Please visit that lecture. It will give an idea, introduction of additional withdrawing group, how much the acidity increases. Why acidity increases? Because the corresponding carbon instability improves, means conjugate acid, sorry, conjugate base. Okay, fine. So this, now it will instantly be deprotonated by the produce this OMe base. So what it will do, this OMe will abstract this and it will come here. Fine. So after that this carbon will generate, and remember this is nothing but a acid base reaction, and acid base reactions are the fastest reaction, so it will happen very easily. Fine. So this will be the product. Now what it can do, see, at the end of the reaction we have used HCl water for workup quenching, so it will be converted into corresponding carboxylic acid. Fine, this carboxylic acid, and this carboxylic acid undergoes facile decarboxylation upon mild heating. Why? Remember, heat is essential. Okay, and why? Because if you look at the molecule carefully, this is the alpha position of the carboxylic acid, this is the beta, this is the beta also. So this is nothing but a beta keto acid, and we know that beta keto acid undergo facile decarboxylation in presence of heat, slight amount of heat, and this thing is favored. I have already uploaded a dedicated lecture on this topic, please visit. Fine. Now this is beta keto acid, and in this way it's a doubly activated. What do I mean? 2 carbonyl group is there on the beta position, so its decarboxylation will be facile. So how decarboxylation can occur? It's through a 6-member transition state. Roughly, let me draw, I guess, sorry because it looks little dirty. So this OH, so it can come here, it can go, come back, and negative charge will come here. And remember, first of all, negative charge will come here, and this negative charge is highly stabilized. Why? This is in between 2 electron withdrawing groups, or in resonance, like active methylene compound, just I have shown here. Similarly, it is stable, so that's why this. And after, so what will happen? This negative charge will consume another one proton because medium is acidic, just remember. So after that it will be converted into the corresponding CH. So this will be the produce. So overall reaction will result in an active methylene compound. Fine. Okay. So I guess you have understood. Now in the second step, what was given? What? Tosyl azide and amine, triethylamine in the first step. So active methylene compounds are highly acidic, and triethylamine is a specific base. You may consider specific proton scavenger. By the way, similar type of property also observed for proton sponges. I have already made a dedicated lecture on this, you may visit. So triethylamine will abstract proton, and what it will generate? These active methylene means carbon ion nucleophile from active methylene compound. So as I told that tosyl azide can react with nucleophile and nitrogen transfer can happen. So what will happen here? It will attack here, fine, and this bond will open up. So the tosyl azide is added with this molecule, fine. Now see, previously it was a 1,3 dicarbonyl compound. Now just look at this molecule. You may consider like this is a tricarbonyl derivative, N double bond, and nitrogen is far more electronegative than carbon. So consequently what will happen? These proton will become very acidic compared to the parent 1,3 dicarbonyl compound. So what will happen? This will instantly abstracted, as I told some time before, that acid base reactions are the fastest reaction, and the nature of the reaction depends on the stability of the conjugate base. So in this way what it will result? So this triethylamine will abstract this proton and carbon ion will be generated here, means this one. So this carbon ion is very important. Why? Because in presence of carbon ion, this Diazo reaction will happen. What happens? This lone pair of nitrogen will push here and it will leave. So leave means in this way it will generate that TS N minus N 2 minus actually, and it will abstract the proton from the reaction medium and it will be TS NH2 ultimately. Now you may think one question that, sir, same NN bond was there previously before deprotonation, so why the deprotonation is essential? Because presence of this negative charge will help this nitrogen such that it can react and ultimately result in a diazo compound. As a comparison, you have seen the diazomethane, and by the way I have already uploaded a dedicated lecture on diazomethane. You may visit for better understanding, fine, many lectures. So diazomethane means the canon structure is this one and this one, and if you this is a moderately stable molecule you may consider, but whenever you protonate this diazomethane, what it produces? This CH3N2 plus. So this CH3N2 plus is not that much stable, it is pretty unstable, and instantly it get attacked by the nucleophile. So what it results? This NO2 leaves, and ultimately this result, this CH3N. So what does it mean? In order to stabilize the diazo compound, one negative charge adjacent to it is essential, because this negative charge participates in resonance to stabilize the diazo compound. By the way, I am not going to explain the resonance thing. Please visit those two lectures for better understanding. And second, another point. You may think that, sir, generally we have observed diazomethane derivative, not other diazo alkanes. But how can you say that this is stabilized? I have discussed one dedicated lecture about carbene generation from diazomethane, where I have explained one specific reagent, ethyl diazoacetate. What do I mean by the name? Ethyl diazoacetate means OET, this and this is the diazo compound, okay, and lone pair is here. So why? And this is means it's a negative charge. Okay, this is pretty stable. Why it's pretty stable? Because the lone pair of electron is in conjugation with this acetate group. So ultimately what it resulted? It resulted this N2 is here, along with that this O minus OET. This. So the negative charge is stabilized and delocalization of electron is stabilization. So presence, you may consider that presence of these two carbonyl is responsible for its additional stabilization. Okay, so this example about ethyl diazoacetate is the proof of concept what I am telling. Fine. So this diazo compound, and we know that diazo compounds are produced, but actually they are not so stable, and they have a tendency for nitrogen elimination. What do I mean by this statement? This bond pair withdrawn by nitrogen and it became a neutral molecule, and another additional point, it's a gas, so it evolves out from the reaction mixture. Okay, and you may consider that enthalpically this is highly favorable because N2 is one of the most stable molecule. Why? Because this nitrogen has a triple bond, very stable. Fine. And second, when this bond pair is withdrawn, it became a 6 electron species, this, that is carbene. Okay, so such chemistry you can understand better about the diazomethane for carbene generation video. So fine, it's a carbene generate, and in the reaction medium what we have used? Oxychloride. And one thing, carbene can be nucleophile also. Okay, so what can happen? That it can react with this butyl oxychloride and produce one OH and one Cl. You may think the story in this way, it's my completely personal opinion. So how the reaction happening? This lone pair can attack this chlorine because it is electron deficient, +1 oxidation state. So consequently it becomes -1, and after attack what will happen? This carbon will become a positive species. Let me draw it for your better understanding. This, so attack with chlorine, and after that it became a positive charge, and see this positive charge is in between two carbonyl group, means highly electron deficient. Consequently what happened? The water molecule present in the reaction mixture, so it will attack here. So ultimately what it will result? Hydroxychloride, and this will further hydrolyzed. Why I am saying hydrolyzed? Because chlorine is a good living group. So what can happen? This lone pair could be pushed here and Cl could be left, and ultimately what it will result? It will result the diketo 1,2,3 diketo derivative. Means you may consider the derivative of Ninhydrin. By the way, I have already uploaded a dedicated lecture on Ninhydrin. You may visit for better understanding. But this Ninhydrin is not that much stable molecule, because see, this is the 1, 2, 3 tricarbonyl molecule and cyclic, severe dipole repulsion. So in order to minimize that, Ninhydrin undergo gem-diol formation, and this middle one undergoes that reaction, and additionally this gem-diol has a stabilization because it can form hydrogen bond with these hydrogens. Fine. So ultimately it will end up here. So this is the product of the reaction. Now, so first of all, what is the product? As I told here, this, by the way, this has a tautomerism with its keto analog, means, sorry, I should have been given this tautomerism in this case also this. So tautomerism means this 1, 2, 3 tri-keto. Fine. Now, so in the question paper, instead of this, they can provide these also, because they are in equilibrium. Okay, so don't get confused if this also given. Now, if such kind of question appears in your exam, how to solve? Very short time. So first of all, when you see ethyl acetate and sodium hydride, you may understand that there is a chance of Claisen condensation, or better, more accurately, this enolate formation. Point number 1. You have to think this, I am writing, but you have to think. And there are 2 ester and 1 ester is more electron deficient, so attack will happen. By the way, if you do the wrong, means by mistake also, if you attack here, you will end up in the right answer. But remember, not only exam, sometime your examiner asks you, write the mechanism or do in front of him. So what happened, if you find out the right answer in a wrong way, that's a negative impression. But if you find out the right answer in a right way, it's a positive impression. And we have observed that examiner have some amount of marks in his hand. So how he or she decide you are a deserving candidate for the full marks of that marks what she has, that could be guided by such kind of activities. So I request you, please try to write mechanism logically, such that your examiner can help you to get better marks. Fine. So first of all, Claisen will happen. So once Claisen will happen, Claisen condensation resulted in 1,3 dicarbonyl compound, more acidic, again it will react, so intramolecular Claisen, and here, so what it can result, you should write the structure of the A on your paper for better understanding. Means this is this, so sorry, heating was, so first of all Claisen, after that heating is there, so decarboxylation will occur, so ultimately it will end up in the 1,3 dicarbonyl compound. Fine, this is the product. Now tosyl azide and base, so you have to understand base means carbon ion generation will happen very easily, so after that it will react with tosyl azide, and ultimately this part is a little difficult, you should write, and ultimately it will result in a diazo compound, and diazo compound could be oxidized, so something else. Now up to this much is enough. Now you have to, maybe this much amount of chemistry is also not needed. First of all, why? See, this is a Claisen condensation, product is 1,3 dicarbonyl compound, you get it. So in this case, second is azide. Azide cannot break carbon, so this option gone, because nitrogen attached to benzene ring, not possible. Amine, not possible, because how amine could be obtained from, for example, diazo compound, maybe reduction. What reagent I have provided? Oxychloride. It's not a reducing, it's an oxidizing agent, not possible. So what left? This, even you don't know the right answer, based on your common sense and slight knowledge of chemistry, can give you the right answer. Okay, so in this way you can get the right answer. So what we have learned today? So in conclusion, we have learned that Ninhydrin could be prepared from aromatic diester through Claisen ester condensation, because it's a very important molecule for detection of amino acids. I have already made a dedicated lecture, you may visit. Fine. Sodium hydroxide is a better choice as a base for Claisen ester condensation than ethoxide or methoxide. Why? Because the reaction proceeds in the forward direction, because the produced hydrogen gas goes outside from the reaction mixture, because it's a gas. Fine. Now active methylene compounds are significantly acidic due to the doubly stabilization of the conjugated acid. Sorry, conjugate base, CB. Okay. Ninhydrin is a very useful reagent for detection of amino acid, and amino acid under very low concentration also. That's why they are also used for forensic people. So this thing you will find in Ninhydrin lecture in details. So this is the end of this discussion. I believe you have enjoyed the lecture. If you really like it, then press the like button, write your opinion in the comment box, and share this video with your friends such that they can also enjoy the benefit. And most importantly, if you think my channel is providing good content, then please subscribe my channel Chemistry, the Mystery of Molecule, and please press the bell icon to get the notification of every single video I upload. So at the end, thank you everyone for watching this video. Stay happy, stay blessed. See you in my next video. All the best.